Hello student, in previous lecture we have seen some problems on duality. That means we have seen some problems how to convert primal problem into dual problem. Now we will see some advanced problems on a primal to dual. So next problem is minimum z equal to x1 plus x2 plus x3 subject to constraint x1 minus 3x2 plus 4x3 equal to 5, x1 minus 2x2 less than equal to 3 and 2x2 minus x3 greater than equal to 4, x1 x2 greater than equal to 0 and x3 is unrestricted in sign. X3 is unrestricted in sign means there is a difference between two variables. Okay, let us see next. Okay, so what is given that? So given problem is in the form of minimization. The given LPB is minimization. Okay, so we have all the sign greater than equal to. We have all the sign greater than equal to. So first we will convert all the sign in the form of greater than equal to. Okay, so here is a equal to sign. So this equal to sign can be converted into two forms, less than equal to and greater than equal to. Okay, the constant involves the sign less than equal to and equal to. First we will convert all the sign greater than equal to, and the variable x3 is unrestricted in sign. So therefore we will replace this variable unrestricted in sign as a difference between two variables. So let us we take the difference between two variables, that is x3 equal to x3 dash minus x3 double dash. Okay, so substituting this in above equations, equation number 1, 2 and 3, then the above constant can be written as, first constant is x1 minus 3x2 plus 4x3 equal to 5. So this can be written as in two form, that is x1 minus 3x2 plus 4. So put x3 equal to x3 dash minus x3 double dash less than equal to 5. So this is the first constant. Okay, that is, so if you multiply this constant to minus 1, so this will become minus x1 plus 3x2 minus 4x3 dash and plus 4x3 double dash greater than equal to minus 4. So this is the first equation of the first constant of this constant. Second equation can be written as x1 minus 3x2 plus 4x3 x3 dash minus x3 double dash greater than equal to 5, that is x1 minus 3x2. So multiply for this bracket, 4x3 dash minus 4x3 double dash greater than equal to. So this is the second equation of the first equation. Okay, so these are the two equations from constant number 1. Now from second constant, given constant is x1 minus 2x2 less than equal to 3. So we want greater than equal to sign. So therefore we will multiply this equation number by minus 1. So minus x1 plus 2x2 greater than equal to minus 3. So let us consider equation number 3. Okay, now the above equation can be written in the standard form. Okay, thus the given LPP can be written in a primal standard form as follows. Okay, so minimum z equal to x1 plus 2x2. So replace x3 equal to x3 dash minus x3 double dash. Okay, then subject to constant. So take the all the greater than equal to sign equations, that is x minus x1 plus 3x2 plus minus 4x3 dash plus 4x3 double dash greater than equal to minus 5. That is first equation. Then second equation is x1 minus 3x2 plus 4x3 dash minus 4x3 double dash greater than equal to 5. This is second equation. Third equation, that is minus x1 plus 2x2 plus 0x3 dash minus 0x3 double dash greater than equal to minus 3. Okay, so here is not a x3 variable, therefore we will take the 0x3 dash minus 0x3 double dash. There will be no change. If you multiply 0 to any number, then it will become 0, because here x3 term is absent. So we can write in this way. Then last equation, so which is already given in the form of greater than equal to. Okay, so that is 0x1 plus 2x2 minus x3 dash plus x3 double dash greater than equal to 4. So this equation is already given in the form of greater than equal to sign. So therefore there is no multiplier to minus 1. Okay. So if you observe here x1, x2, x3 dash and x3 double dash greater than equal to 0. Okay. So this is the primal standard form of a given LPP. Now we will take the dual of this primal standard form. Okay. So there are one, two, three, four constants. So therefore we required 4 dual variables. Okay. So let us we take that dual variable w1 dash, w1 double dash, w2, w3 are the dual variable corresponding to the primal constant. Okay, because there are 4 constants we already discussed in algorithm. So 1, 2, 3, 4. Therefore we required 4 dual variables. So let us we take that dual variable is w1 dash, w1 double dash, w2 and w3. Then the dual of this problem can be written as, okay, here is a minimum, so therefore dual of this, that is maximum z star equal to, so this will becomes objective function, and x1 x2 will becomes w1 dash, w1 double dash and w2 w3. So therefore the objective function can be written as maximum z star equal to minus 5 w1 dash plus 5 w1 double dash minus 3 w2 plus 4 w3. So this is the dual variable objective function subject to constant. So this column will become row. Okay. So w1, that is minus w1 dash plus w1 double dash minus w2 then 0 w3 less than equal to first coefficient of first variable is 1, less than equal to 1. Second column will becomes row, that is 3 w1 dash minus 3 w1 double dash plus 2 w2 plus 2 w3 less than equal to 1. Okay. That is problem is in dual form, that is maximum z, then all the sign less than equal to must be less than equal to, and third constant. So this column will become row, minus 4 w1 dash plus 4 w1 double dash plus 0 w2 because w2 is absent minus w3 less than equal to 1. So this 1 1 1 these are the coefficient of x1, x2, x3 and x4. Okay. Then last term, that is 4 w1. So last column 4 w1 dash minus 4 w1 double dash minus 0 w2 because here w2 term is absent. Okay. Then plus w4 less than equal to minus 1. W3 less than equal to minus 1. Okay. So here w1 dash, w1 double dash, w2, w3 greater than equal to 0. These are the dual variables. So this is the dual problem of a given primal problem. Okay. Now if you observe here w1 dash and w1 double dash and w1 double dash minus w1 dash equal to w1 star. That means there is a common difference between a two variable. If you observe, if you take 5 minus 5 from this, if you take 5 common, so you will get w1 double dash minus w1 common difference. So here you will get common difference here. Okay. So if you observe from this problem, there is a difference between two variables, that is w1 double dash minus w1 dash. Okay. So let us we take that difference. Difference is a unrestricted variable, that is capital W1 star. Okay. So here every common unrestricted variable is replaced by the difference of the two variables, and that difference is given as w1 dash minus w1 dash equal to capital W1 star. Okay. So let us we take the, okay, therefore the required dual problem is given as maximum z as it is. Okay. So take 5 is common, so you will get W1 double dash minus W1, that is capital W1 star. So this is a capital W1 star. Minus 3 W2 plus 4 W3 as it is, because here is not a common difference. If you observe, here is also not a common difference. Okay, so common difference should be in each equation and in objective function. Okay, then the required dual problem. Okay, then subject to constant is, so this is a difference between two variables, that is we denoted as W1 star minus W2, 0 W3 is not required to write here, less than equal to 1. Then second equation minus this equation 3 minus minus 3 W1 star plus 2 W2 plus 2 W3 less than equal to 1. And last equation, this equation, so we can write capital 4 W1 star minus W3 equal to 1. So we can write directly this equation, because there are two equations. Okay, so if you solve this equation, so this is the equality sign. If you solve less than equal to and greater than equal to, that means these are the unrestricted variables. Okay, if you solve this, so you will get the equality. So from these two equation we can write directly 4 capital W1 star minus W3 equal to 1. So here W2 and W3 greater than equal to 0. These are the dual variables, and capital W1 star is unrestricted in size. So this is the complete solution of the given LPP. How to solve the problems, or how to obtain the dual problem from a given primal problem.